Have you ever thought about what actually happens the very millisecond you hit enter on a web address? Data instantly rushes across the globe to bring you the exact page you asked for. In a standard internet connection, your computer, the client, talks directly to the website's computer, called the server. To make this exchange, your device sends out a request packet, and stamped right on that packet is your IP address. That IP address is essentially your digital street address. You have to hand it over so the website knows where to send the data back to you. Because you are connecting directly, the website sees who you are, where you are, and keeps a record of your visit. To solve this privacy problem, you can place a middleman between your computer and the internet. We call this a proxy server. When you use a proxy, your request goes to this middleman first. The proxy takes your request, strips off your personal IP address, puts its own address on the packet, and forwards it to the website. This simple swap changes the whole interaction. The website only sees and interacts with the proxy, which shields your true identity and location from the destination server. The most common type of middleman is called a forward proxy. You can think of it as your personal digital assistant, working specifically on your behalf to handle your outgoing internet requests. This assistant handles a few major tasks. The first is privacy. Because the proxy replaces your IP address with its own, you can use a proxy located in another country to request a website. The site sees the proxy's location instead of yours, bypassing regional blocks and giving you access to restricted content. The second task is filtering. Schools and businesses use forward proxies to enforce rules. When a student or employee tries to visit a restricted website, the proxy checks the request against a block list and stops it right there, preventing the device from reaching the site. The third task is caching. If 50 people in an office all visit the same news website, the proxy doesn't fetch the site 50 times. It downloads the page once, stores a local copy in its memory, and simply hands it right back to the other 49 people instantly, saving the network a massive amount of bandwidth. This image shows the internal architecture of how a proxy manages these complex tasks. You can see the specific modules it uses to operate, like the connection manager that routes the requests, the cache manager that stores those local copies we just mentioned, and the log manager that records the traffic activity. A forward proxy is a defensive tool for you and your network. It manages and protects your outgoing traffic before it ever leaves for the wider internet. Now, let's flip the perspective. What happens when the middleman works for the website instead of the user? This is called a reverse proxy. A reverse proxy acts as a bodyguard and a traffic cop for major web servers. Instead of hiding the user, it hides the website's internal servers from the public internet. When thousands of visitors try to access a site at once, the reverse proxy intercepts all that traffic and balances the heavy workload evenly across multiple backend servers. Whether you use a forward proxy or a reverse proxy, the tool's effectiveness depends entirely on where its IP address physically comes from. The most common type are datacenter proxies. These are IP addresses generated by large commercial server farms. They are incredibly fast, highly available, and cheap to use. However, because they come from a data center, websites can easily identify them as commercial traffic rather than a typical home user. On the other side, we have residential proxies. These use real IP addresses tied to actual physical homes and local internet service providers. When you use a residential proxy, your traffic looks exactly like it's coming from an everyday person sitting in their living room. This origin distinction matters. Websites will often automatically block data center proxies, assuming the traffic is from an automated bot, but they will allow a residential proxy through because it perfectly mimics a legitimate human visitor. At this point, you might be wondering, if a proxy hides my IP address, how is it any different from a virtual private network, or VPN? The difference comes down to how much of your device is covered. A proxy works inside a specific app, like your web browser. It's like sending an assistant on one errand for one app. Because it's just passing data back and forth as a simple relay, it's a very fast, direct process. A VPN handles the entire device's connection. It wraps all your internet traffic in heavy encryption, which is a way of scrambling your data so nobody else can read it. It acts like a secure, armored tunnel for every single app on your computer at once. The trade-off comes down to how much work the middleman has to do. Since a proxy is just a simple relay, it stays fast. But a VPN has to do the heavy lifting of scrambling and unscrambling every piece of data, which can slow your internet connection down. As a rule of thumb, use a proxy for targeted tasks like web scraping or getting around a regional block in your browser, but use a VPN when you need that scrambled security for your sensitive data, especially when you're using a public Wi-Fi network. Understanding whether you need a nimble relay or a secure armored tunnel allows you to choose the right tool for however you want to appear online.